Okay, Jeroen, let's get started. Okay, go to the next slide. So welcome everyone at today's webinar. Your hosts for today are, first of all, myself. My name is Joey. I'm the marketing manager here at Actual. And on the other end of the screen is Jeroen van Disseldorp. He's the CEO and founder of Actual, and he will be giving the presentation of today. So
Hello.
Hey, Jeroen.
Hi, Joey.
Before we get started, I wanted to give you guys a quick heads up. You can go to the next slide. So this will be recorded, and after this webinar, I will send out the webinar slides and recording. And if you have any questions during this webinar, please feel free to submit them in the Q&A box on your right-hand side. We will have a live Q&A at the end of this webinar, where we will answer your questions. And well, that's it for me. Let's go over to Jeroen.
All right, thank you, Joey. And hello, everyone. Today, we're going to be talking about standardization of Kafka in an enterprise context. So before we dive into the content, let's take a look at, how companies actually go through a series of steps in enterprise adoption of Apache Kafka. And this is a model that was drawn by Gartner. It's the maturity model for event-driven architecture. And it depicts companies as going through a series of steps in adoption of event-driven architecture with Kafka as one of the tools to do so. So initially, there's usually a phase in which there is nothing arranged formally around events. So that's the incidental phase where applications, they usually make bilateral agreements about how to exchange events. And that could be done on any medium like MQ or through files or in whatever way they want to exchange the information. At some point, usually we see that, especially in project contexts, all of a sudden a Kafka broker is brought in because this is a good idea and the project benefits from it. And it's really, low threshold to get started with it. So then we enter the brokered phase. And typically what we see is that, many organizations do that, and it's easy to do, but because it's easy to do, many projects also start doing that in an organization. And it's not uncommon for a company to all of a sudden have maybe 5 or even 20 Kafka clusters running somewhere, all with different levels of availability requirements, different levels of maintenance procedures. So at some point, it also makes sense to do away with all the unpredictability and to go to a centralized Kafka. And a centralized Kafka is like the next step for converging all of the decentralized Kafka to. It's just that if you implement this centralized Kafka, a lot of companies typically get stuck there. Because, it proves that centralized Kafka is not so easy to implement. And why is that? Well, due to a number of reasons. So typically, the organizations nowadays are organized in a DevOps kind of way. So with different teams acting as autonomous representatives of the company towards their own markets, towards their own customer segments, having their own products. But then they are still expected to integrate on the backend event platform, which may or may not always be suited to that need. So typically there's 3 ways to implement such a platform. First is to basically open up everything. This means that the event platform itself just becomes a transport mechanism. Anybody can communicate with anybody without too much interference. So each party can just set up communication, agree with somebody else on that same communication, and the event platform will facilitate that. Typically, that is how LinkedIn even got going. Back in the day when Kafka was developed at LinkedIn, there was no security. It was just a platform that took care of transport for all the messaging data without too much guidance and policies. Of course, nowadays, this is not possible anymore. There are so many data regulations, GDPR compliance, things that you have to take care of, that implementing it as a free-for-all on an enterprise scale is not an option anymore. Another way to implement this is to basically put a central Kafka team in place, which then gets all the authority to configure Kafka in just the right way, to enable all the use cases, and to make sure that no strange things happen to the data that is transported through the event platform. We actually used to be one of these teams when we were still with some of our customers on-prem. This central Kafka team was formed by us, and we definitely have some good memories of back in the day, because typically you get a lot of challenges like this. So we used to be approached, being asked by teams, can you roll out this topic? I've tried to produce a message to the topic. Did you see my message arrive? Who's the maintainer of this particular schema? I have an application that is allowed to be used in test, but not in production yet because we don't have the license to go to production. But can you please connect us to the test environment, etc., etc., etc. There is a slew of tasks to take care of when you are the central Kafka team. And it doesn't have anything to do with the technical side of maintaining the platform, keeping it up and running. It just has to do with fulfilling all of these requests from the teams that want to integrate their applications, develop their applications for Kafka, and then finally run their production systems against a production Kafka. So we soon came to the conclusion, well, this is also really not the way to go, because it's not scalable, and it's definitely not a solution that gives speed to an organization, because ultimately everybody will be waiting for this new bottleneck that we just created in the organization. So the other way to really implement this is to implement it as a multi-tenant platform. And this is particularly what we will be talking about today. So how to implement Kafka as a multi-tenant standardized platform in an organization. We're going to discuss a three-step approach. First of all, get the technology in place. So what kinds of technologies do you need to put in place? What does that look like? Then onboard your first teams. And finally, evaluate what you've built with your first use cases, promote and scale in the rest of the organization. So let's look at the technology. What technology do you need to get such a common building block for all your teams in place with Kafka? Typically, Kafka itself in such a situation will be seen as a central hub where all of your departments connect to. So when they do, they will exchange messages in probably their own jargon. And one of the challenges is, of course, to make that jargon as understandable as possible to the rest of the organization. Talk events in business meaningful terms. Make sure that there are no obscure event types, but that everybody can understand what you're actually communicating about. But this is very much possible. But to implement a platform like this, you need to take care of a few things. Typically, you need to still have that streaming platform in place, but especially you need to have data governance on top, which enables all of the teams to do their own thing. Just to peel this off a little bit, the infrastructure is, generic cloud or on-prem infrastructure, I would say, nothing too typical about that. The streaming platform itself, this is where you deal with Kafka clusters. If you have multiple Kafka clusters, this is also where you would expect message and offset and schema synchronization, some technical bits. But ultimately, there is a technical maintainer here that makes the platform available and performant for all teams to use. The teams themselves, to have optimal scalability and to really see this as a multi-tenant platform, they need to be able to do their own thing on the platform, meaning that they log into a self-service environment where they can set up topics themselves, they can define applications themselves, they can decide who gets ownership to their own topics. And this whole game should be facilitated by the platform. Of course, these teams, they still write their own applications. So the producers, the consumers, and the streaming applications, They, of course, interact directly with Kafka without interference of the governance layer itself. The governance layer itself is purely meant as a configuration tool to make sure that all configuration on Kafka is consistent and in line with company policies and data regulations. But besides having that UI, there should also be different kinds of entries into the data governance layer, particularly through a CI/CD API. And also we see a lot of organizations nowadays wanting to put their topic definitions, their access grants, etc., in their own Git repositories, and then have them deployed through Terraform or some other means through a GitOps way into the streaming platform. Well, and those two layers combined, so the streaming platform and the data governance layer combined, I would say that that makes a total streaming platform, an enterprise streaming platform. So without data governance, it's very difficult to scale, to collaborate without the organization worrying too much about potential violations of compliance. So some takeaway for what are the key requirements for having an enterprise Kafka? Typically, you need to worry about data governance features, who can do what, who has authorization to do what, who do I trust to make the right decisions in the configuration of this big platform. Finally, if you have that, if you have that authority, then you should also have the tools to do that, and that is all encapsulated into self-service. And of course, the security should very much be in place, so there should be no discussion about any validity of the security. That should always be adhered to. Okay, so then we have a Kafka platform in place. And then the next step would be to onboard your first teams. So how to go about that? Well, we've actually named a few teams here. So we're going to go through them and to see what typical needs they have and how they can be helped with the onboarding on the platform. So typically, first we look at a development team, a team responsible for application, for one or more applications that wants to interact with Kafka. So there's some general topics that you should introduce them to, of course, into Kafka itself. General concepts like, how do topics work? What are partitions? What are offsets? What are consumer groups? Those typically form the basis of what a team needs to know in order to understand the model behind Kafka and what the server side expects of them. Then, of course, a high-level understanding of event-driven architecture. They're going to implement probably something event-driven. That means that they should have an understanding of what an event is, what makes the trigger of an event, how events may be consumed, and of course, how the platform is going to be used. Particularly how ownership is implemented, because around ownership, there are definitely some responsibilities that they need to be aware of in such a way that they can efficiently collaborate with the rest of the organization. Well, and then typically on a development team's mind would be, what are the technical aspects of Kafka? What kinds of frameworks can I use? What kinds of, implementation alternatives are there? What produce and consume strategies are? So you can have at least one strategy, at most one strategy. How to work with acknowledgements on Kafka. These are typical questions that we do get to see a lot. How to work with data schemas, what a schema registry is, policies around that. And finally, especially in the beginning, it's also important to have a potential go-to place to have their designs validated. In the beginning, people may be a little uncertain about their own designs. Is this going to work for me? Is this the way it's supposed to be done? So can you please review my design and give me some comments? All these activities, they will generally help the development team a lot. and will make the onboarding really smooth. Next, we also have a data team. Data team would be somebody or some group in the organization responsible for the formal side of data. So a group that is responsible for customer data or for transaction data or for energy data. Typically, such a group also has a role in the platform because they need to have and maintain ownership of that data on the platform. And they also have a way to exercise control over that data. So typically, they also need to have a general understanding of what event-driven architecture is, how it works, and how their data is going to play a role in improving the efficiency of the organization. Of course, they also need maybe some more training into the platform usage. Because, what we find over time is that some of these data teams, they don't necessarily have all the technical baggage to quickly get a grasp what the platform is about and how to use that. So how is ownership implemented? And what responsibilities do you as a data owner have in this platform? What is expected of you? And then typically subjects that are a little bit more specific to data teams is how to model data schemas, what makes a good business event, what is a not so good practice in business events, what is schema evolution about, how to implement next versions of schema and how to maintain backwards compatibility and make sure that existing systems don't topple over when you introduce a new version of your schema. Of course, the design validation in the same way as with the software team is also important. Especially at first, they may not be so sure about their message design. Is this going to work? Does this adhere to standards? Did I make mistakes? So having a way for them to have those designs reviewed is definitely something that will help the onboarding and gaining confidence in using the platform. And then finally, how to grant and revoke access rights, because typically what a data team can do is to define a topic, to put a schema in place for that particular topic. But then there's like a continuous responsibility of a data team to maintain the right set of applications with access in the platform. So if at any point in time there's a data or there's an application supposed to be decommissioned, sometimes they are set to be decommissioned, but they still run somewhere because not all instances were turned off or something like that. And so the data team is responsible for if there's like a formal end of access grant associated with the data, to just remove the access for the application, and it can no longer access the data on that particular topic. So the responsibilities of having that right, and that should be totally clear, crystal clear with the data team. Of course, we talked in the reference architecture already a little bit about the separation of concerns between functional maintenance and technical maintenance. So these development teams and the data teams, they would be considered to be the responsible teams for the functional maintenance. Of course, if you're in an on-prem situation or you run your own Kafka platform, there's also a platform team which is responsible to do the technical maintenance. And this team may also need to be enabled. Sometimes the team that does the installation of the platform is not necessarily the team that does the platform maintenance. So let's also take a look at what the platform maintenance team is supposed to do. Again, these general subjects into Kafka, so how to position Kafka, how to position event-driven architecture, and of course the platform itself. So what does it do? Who are its customers? What do these customers expect of the platform? What is the service level agreement that we internally defined along with the platform? All of these things need to be communicated so that they know what they're up against. And then specific, subjects to make sure that they grasp the maintenance. So talk about platform architecture. What did we set up? How is it installed? Where do we find all the machines that run this software? How is it interlinked with all of the rest of the enterprise systems for authentication, for storage, etc.? What are the typical maintenance procedures? So how do we ensure that we achieve the service level internally by making sure we preemptively do a number of tasks, and we don't let disks running full, to just name one thing. And of course, once there is an incident, how to approach incident analysis. We've seen over time that incident analysis on Kafka can be quite complex. So having a team that is comfortable with, looking into technical components, checking out configuration options, knowing which components internally communicate with which other components, that is a big speed up in case of incidents. So that is all part of the enablement of the platform team. And of course, there are other enablement activities as well. In general, well, you do want to give the right trainings to the right people. It's not just these teams that I just showed, but in general, there's a multitude of teams involved with, well, the applications connecting to Kafka. So having a learning culture is very much appreciated. People need that. They need to get comfortable with event-driven architecture. They need to get comfortable with well, the technology itself, but they also should be comfortable with making mistakes, because especially in the beginning there will be some mistakes made, but that's all fine. So it's a way to get going, but making those mistakes and learning from those mistakes is already better than not having a platform and doing nothing at all. So the best way to learn from these mistakes is to also provide access to internal external experts, so that these reviews can take place, messaging schemas are reviewed, designs are reviewed, and by discussing about the steps taken and what steps could be taken differently, people can really learn a lot. Well, optionally, if you have the resources, you can set up some sort of an internal academy where you have standardized courses for teams that want to onboard, for sharing experiences. And of course, what is very appreciated is to invite the business here, have them articulate business use cases and needs, so that you can use these examples as as use cases to develop your learnings on. There's nothing more rewarding than a business person that comes along and says, well, we should really go there, and this is like what I would like to see, and so how can eventing help in this? And then, well, as the cogs in people's heads starts turning, you can see that there's a lot of inspiration there for solving these real business needs. So the more practical you can make this, the better it usually lands. Of course, next to that, you also have like the non-personal training that you can do, building up reference materials, so how-tos and internal wiki pages on how to onboard, how to model schema, etc. Definitely provide examples for schemas and also examples for code, code in maybe different languages, code with different frameworks being used, but something to not have to start from zero. And that will also help to speed up the teams that want to integrate with Kafka. And then finally, once you have all that going, of course you need to evaluate, promote, and scale, meaning that you should learn from your experiences. Once the first use cases are implemented, you'll find that there's some good things experienced and some not so good things experienced. Especially in the beginning, it's really important to pick up on these experiences, highlight the good ones and improve on the not so good ones. It is definitely rewarding to have successful use cases showcased in the organization. I've seen it with a couple of customers in the past. As soon as they had 2 or 3 use cases, they did a little internal roadshow where they just have had the project leaders, the business owners, but also the technical people present what they implemented. And the combination of the three is really powerful because the business need, the use case, the business value is then communicated along with how this is implemented. So people from both business as well as IT, they can really learn from the closeness of the interaction between business and IT in this case. So in that sense, having an event-driven architecture, you're really spot on delivering business value. So it's really quite inspiring to see how these use cases composed of different business and IT people, how they really are implemented, and sometimes even in very, very short times. And then finally, to scale, there's a lot of ways you can scale, but in general, it would be nice if you can somehow build up a center of excellence on event-driven architecture internally. This is like a community where people that have experience with implementing Kafka, but also people experience in formulating business needs, in requirements around Kafka, where they come together and they can build out your next level of standardization. In terms of what policies you want to implement, in terms of it could be anything around naming conventions, modeling conventions, maintenance conventions, ownership conventions. This is really a place where you evaluate how you're implementing this, and you also think about how to improve the next step of implementing your event-driven architecture. So to sum up, the three-step approach: get the technology in place, onboard your first teams, and evaluate, promote, and scale. And this is like the general pattern in which we implement many Kafka platforms in organizations. And we hope that this makes sense and that you can use the same model in your own organization to make Kafka a true success.
Perfect. Thank you very, very much, Jeroen. That was quite insightful. Now it's time for the live Q&A. So if you have any questions about Kafka, about data integration, about topic management, now is your time to ask us. I think Jeroen and I will stay here for, a couple of minutes, and I've already seen a couple of questions coming in the Q&A box. So let me open up the Q&A box. Do you see them as well, Jeroen?
I see two questions here.
Right. So the first one, hi, could you please guide more about schema registry, how and when to use and for which services, how to register schema for producer and consumer applications, and about schema registry?
Yep. So yeah, generally in a Kafka platform, schema registry is used as a means for producer applications to signal to consumer applications how they encoded a message. In general, you have like a landscape of applications around Kafka. It is for any particular topic, it's like an illusion to think that you can all go from message version 2 to message version 3 just overnight. There's almost never a stop the world scenario where everybody upgrades their software at one point in time and then restarts it, and then you're all on a new message version. So what generally happens around Kafka is that you use data schema and schema evolution practices. And a typical framework which is used a lot is Apache Avro, which is a messaging schema that allows you to up convert or down convert messages. So you can have producers that produce in message version 3, and you have consumers that could consume the same message in version 4. And the way that Avro does this is by guaranteeing upwards and downwards compatibility. The reverse could also hold. You could also produce a message in version 4, and it can be consumed in version 3. And this is all to not have any unforeseen circumstances where I'm missing out on fields, or I have to take care of all of these different versions at the same time. This is really something that the framework solves for you. And the schema registry is like the independent place where the interaction between those schema happen. So a producer registers the schema that he produces with, and also links that into the message. The consumer gets a message, sees a schema ID, loads that schema ID from the registry, and then together with the schema ID that it has itself, it can convert the producer's message into the message version that it expects. So that is the role that a schema registry plays. I hope that answers the question.
Okay, see another one, also from anonymous attendee. I'm not sure if I get the question generally, which type of issue is getting for Confluent Kafka? Do you get the question, Jeroen?
No. Don't really understand what the question is.
Maybe if the person is still in the webinar, he can rewrite or rephrase the question. All right. I see another question popping up. Let's move on. What role does a data architecture team play with the streaming platform in terms of data management and data lineage?
What role does a data architecture team play with the streaming platform in terms of data management and data lineage? So the data architecture team, so what a data architecture team typically is interested in is, the flow of data across an organization. So, and I think what they're interested in is apart from the technical flow itself and how data is transformed, also to ensure that the compliance rules are met. And I think what I presented in the picture, if you follow this reference architecture for the Kafka platform, then you get compliance out of the box. So that means that authorization to applications is only awarded by the respectful data owners, meaning that they have the responsibility themselves on who gets to access what particular pieces of data. Well, if that is taken care of, then of course you can look at the functional aspect of that data management and lineage. So the platform itself is able to, or should be able to, provide you with lineage pictures. So how does data flow across Kafka? Meaning that one application can produce to a topic, it can be consumed by a second application, transformed into something else and put on a second topic, and so on and so on. So all of these interactions between producers, consumers, and topics, that is something that is modeled normally in, on a technical level, that is modeled in the Kafka configuration, because the authorizations are dependent on that. But on a higher level, this is something that can be visualized in data flow diagrams. And the architecture team is typically not responsible for neither data itself, because data elements are usually owned by other people in the organization, and they're also not responsible for applications, because that is typically also owned by somebody else. So, but the data architecture team, I would say, is generally interested in applying the right policies, making sure that those policies are adhered to, and also not losing control. And I think that last aspect of not losing control, that is what you get with a proper platform that allows you to visualize, who manages what data and how does data flow across the platform. So in that sense, what role does the data architecture team play? I would say they are the wardens that make sure that they have complete transparency about what's going on the platform. So they are the wardens that take care of the application of general policies in the organization.
Cool. Thank you very much, Jeroen. I also got a couple of questions that came in via email. Let me read out the first one. Can you use Actual on top of other Kafkas? If so, what kind of Kafka providers do you support?
Yes, so the streaming layer itself is completely detached from the governance layer that Actual provides. So the idea is that you can put that governance layer onto any Kafka. And currently supported is on-prem, Strimzy, Kafka, Confluent Platform, Confluent Cloud, and Haven, and of course our own Actual Kafka.
Right, cool. Another question, how long does it take to implement such a Kafka platform?
That generally depends. In cloud, it's a matter of, well, days, I would say. The most critical aspect is to get the security in place, meaning that you need to connect to an organization's identity and access manager. You need to have all the right security credentials and certificates in place. But that's the most complex part. On-prem, that really depends on the infrastructure and, well, the same provisioning of these dependencies. But, well, any typical implementation project, I would say, is between, well, 3 weeks and 3 months.
Okay, I think we run out of questions, unless someone has a question right now. All right, let's call it a day. Thanks everyone for joining this webinar. I hope it was insightful. I will send out the recording and the slides tomorrow, so you will receive an email from me. And let's stay in touch and have a great evening, everyone.
Thank you, Joey.
Wait, Jeroen, I see one more question, please.
Somebody is typing.
Yeah, I guess so. All right, one more question. There it is. Question from Wout. Does Kafka need to back up?
Does Kafka need to be backed up? Oh, that's an interesting question. We've philosophized about that quite some times. It depends on what you see as Kafka. Part of it, yes, part of it, no. And let me explain that. So what is very difficult, you should imagine that Kafka is a 24/7 system. And there's a lot of data flowing through Kafka, which means that applications produce and consume all the time. And it's really, really easy to make a snapshot of a particular situation. So I can do a snapshot now, and I will snapshot all of the data that resides on Kafka. I will snapshot all of the offsets where consumers are at the moment in consuming the data streams. So that is definitely something you can do. The thing is, we've never been able to really define what a restore of Kafka means. Because right after the snapshot, production and consumption will still consume, will still go on, which means that your consumers will have already seen the messages that they consumed after that. So if you restore a backup and you would reset all of the consumer offsets back to the moment of the snapshot, it's really difficult how you would want to define that for a general business application. So that's why we've kind of made a selective policy out of backing up. So the things that we do tend to back up are compaction topics, because a compaction topic can be filled in years. Some of the data on the compaction topic can be produced, I don't know, in 2020 already. And it's going to get consumed somehow or get joined in a transformation sometime next year. So those are the kinds of topics that you do want to back up. And restores there also means something. So you want to restore this index where you're doing lookups. But typically for the general purpose data streams, the deletion data streams in that sense, we've never come up with a good model on how to do this transparently. Because at some point, this general platform means that you have to somehow generally think about what it means to an application to do a restore. Should they just expect that a restore can happen and they receive all the messages since again? But then again, the messages that were produced after you did the snapshot, those are not in the backup. So does that mean that they will never see those messages again? It's a really ambiguous situation. So that's why we tend to just back up the metadata of Kafka. We tend to just back up compaction topics, but not the actual data streams. I hope that makes sense.
Good question, Wout. Let's call it a day. Thanks everyone for joining, and
right.
enjoy your evening. And thank you, Jeroen, for the presentation.
Thank you. Bye-bye.
Cheers, everyone. Bye-bye.